Okay, students, this is Mr. Coots here, and I will be explaining the 3.1, the diving problem that we started working on yesterday. So first, let's read the question. It says, you jump off the 10-foot diving board at the local pool. You bounce up at 6 feet per second and then drop towards the water. Your height in feet above the water at time t seconds can be modeled by the function this. Okay, so first let's talk about the function notation. Then we'll get down to the basics. Okay. Well, before we do that, in fact, let's see if we can just visualize the problem. Okay. So what we have is we have a ladder, a diving board, and you. Okay, because it's you. You jump off the diving board, and it's 10 feet high, so we know that's 10 feet tall. Oops, that's kind of messy. That's 10 feet. Okay. And it says you bounce up, and then come down towards the water. There's the water. So that's what we expect to happen. So how's this equation related to it? Well, this function is a function from physics, and let me try and explain a little bit about what numbers are here and what they mean. Start with the back of the 10, and you notice that you start on a 10-foot diving board. That is correct. That is why the 10 is there. Okay. Physics and calculus will help you discover exactly where that equation came from. What I'm going to sort of focus on is how do you use it, how do we use the notation and stuff like that, the mechanics of it. So 10 feet is that. You bounced up at 6 feet per second. That's where that goes. And then this part is from gravity, and you'll, again, learn all about that in physics and why it is and how they discovered what it was. All right. For us, though, what we're going to try and do is graph this function. And first, we're going to need to do a table of values. Okay. So with the table of values, you can do any points you want, except for they're telling you do tenths of a second. So let's do this. 1/10 of a second would be 0.1 seconds. That's what they mean. Okay, because what happens is if you count a 1 1,000, 2 1,000, he's in the water before 2 seconds. He's not in the water, he's not in the air for very long. So our table of values would usually go x and y, but you'll notice we don't have any x's and y's. So let's explain what this is. Instead of x, it says x is going to be on our horizontal axis is t. So instead of x, what we have is t. Instead of y, we have h of t. That's all this is. It's not h times t, it's called h of t. It's all it's saying is your height is a function of time. So we're going to start with 0, and then we're going to go every 0.1 seconds. So 0.1, 0.2, 0.3, 0.4, until he reaches the water at some point. Now, how does this notation work? Let's rewrite the function here. Okay, so here we go. Here's how we're going to do this. When t is 0, we write it as h parentheses 0. That means h, the height, at time 0 is equal to -16. And then I'm going to rewrite my function, but I'm going to put parentheses. I'll show you why in a moment. Okay, so there we are. And we're going to plug in 0 and 0 for the time. So that's why. So instead of t, we're replacing it with 0 because we're finding out at time 0. Plug in 0 for time and find out what it's doing. So if we calculate this, 0 squared is 0, times 16 is 0, 6 times 0 is 0, and then you have the plus 10. We don't need a plus, just 10. Okay, just 10. So that's actually 1 point now. So we have 1 point on our graph. If we figure out the rest of these, well, then we'll have all the points. So let's do this. For the rest of them, it's going to work very much the same. The notation, and I'd like you to try and write this notation so you get used to it. It's kind of weird, but once you realize it's just substitution, then it's not so bad. And what are we substituting this time? 0.1, so we find out where we are at 0.1 seconds. Okay, so for 0.1, this is going to be kind of some work. So I'm actually going to turn it over to the calculator to do it. And see if we can avoid that glare. Sorry guys, let's adjust this. Okay, let's do that. So our equation needs to be negative negative 16 parentheses 0.1 squared plus 6 parentheses 0.1 parentheses plus 10. Sorry about that. So that's how it looks when it's typed in. Press enter, and you got that. Okay. So now we know after 1 second, he's at 10.44. We'll write that in on our table there. Okay. Now here's the real power of these calculators. If you go second and then the enter button, it brings back everything you just typed. And now we can just change this to a 0.2. A 0.2. All right. And then if you want to do that again, go second, enter. And let's change everything to a 0.3. 0.3. And so you can go through like that. So the table of values shouldn't take a whole lot of time if you have the calculator. And if we do that, we should be able to analyze this thing. And one thing to quickly mention here, these calculators will do the same thing. They have the display, so you go negative 16 parentheses 0.1 parentheses and so on and so on. So you can type it out and see it all up there. That's pretty nice to have. You can also get one of these calculators from Dollar Tree. The difference is the screen's not as big. You won't be able to see both lines of display where you typed in what you typed in and then what it equals. So, but they will get the job done and things like that. You can also use your phone. Just make sure your whatever calculator you're using, if it's a scientific one like these, is automatically going to know the order of operations. If you get anything other than this, we need to go back and check your answers. So go ahead and finish up the rest of the first table, and then we're going to graph them. That way we can actually start analyzing the domain and range. All right, good luck with your groups.